Good morning all. Myself Ramya, working as Assistant Professor, Department of EC at Hindustan College of Engineering and Technology, Coimbatore. I am here to discuss about image enhancement in spatial domain, under that gray level transformations, which comes under the subject of digital image processing. So image enhancement's main purpose and main objective is to make the image which is more suitable than the original image. So it has to be made better for visual perception, and this algorithm may differ according to the application. The image enhancement can be spatial domain or frequency domain. And what is image enhancement? The image enhancement is the process of making the images more useful, and actually the image enhancement is performed to highlight the interesting detail in the image and to remove the noises present in the image and make the image more visually appealing. So for example, this is the image, and here I cannot able to visualize the spines better, so that it has to be enhanced and it is made better here. So image enhancement is making the image in a better form such that the visual person can able to understand it in a better form. And for example, for the doctors also, image processing will be helpful. If this is the image provided, it won't give you much detail, so that it is enhanced and provided. And here the noise has been affecting the image, which cannot help the industrial inspecting person to identify the fault properly, so that it has been enhanced by means of removing the noise, and it is provided for further inspection. And likewise here in this image, the first image, so wrinkles are there. It has been enhanced by means of smoothening that area. Likewise, if you smoothen that area, the wrinkles won't be there, so image has been enhanced. So image enhancement can be categorized into two. One is spatial and another one is frequency domain. If you operate directly on the pixel to improve the appearance of the image, it is called as spatial enhancement. If you apply on the Fourier transform of the image, it is called as frequency domain image enhancement. If we take the spatial domain enhancement, if we directly operate on the pixel, it is spatial domain. So g of x comma y is a response which is obtained by means of applying some transform operator to the input pixel f of x comma y. So if it is just one pixel, and if you are applying the operator on that one pixel, it is called as point processing. R is the gray level, input gray level, and S is the output gray level. So the point transformation can be given as S is equal to T of R. These are the various spatial domain methods, particularly point-based processing methods. We will see one by one. The first we are going to see is point-based methods, which is these point-based methods involve linear transformations, logarithmic transformations, and power law transformation. We will see one by one in detail. The first category is linear transformation. In that, negative transformation. Negative transformation is that when you provide the input gray level of 0, it has to provide us L minus 1. L is the maximum gray level. 0 to L minus 1 is the range of gray levels which are available to represent the image. Means if it is 0, the input gray level is 0, output gray level is L minus 1. And if the input gray level is L minus 1, output gray level can be 0. In short, this negative transformation provides a negative image. If white means black, black means white. Okay, so this is a negative transformation. This is given by the expression of S output gray level is equal to L minus 1 minus R. So every input pixel is taken and applied with this transformation, and the respective output gray level is obtained. So this is the input image, and if you represent it directly, this is identity transformation. If you apply negative transformation, you will get this type of image. Where this negative transformation is applied is in case of identifying the tumors. For example, in mammography, this negative transformation helps to identify the lumps present. And the next transformation is log transformation. Log transformation is applied by means of the function output gray level S is obtained by C log 1 plus or C is constant, where the input gray level is assumed to be greater than or equal to 0. So this log transformation tries to map the narrow range of low input gray level to the wider range of output gray level. That is, it tries to expand it. So log transformation, see from this image it is very much clear. This is the input image. When you apply log transformation, every minute gray level, dark gray level has been expanded. So I can get the expanded form of representation. So image can be enhanced better by means of logarithmic transformations. An inverse transformation tries to compress the range of gray levels. It tries to expand. Log transformation tries to expand. Inverse tries to compress. So this is log transformation and this is inverse log transformation. So when you apply log, it is brightened. See, it is more brightened, and this is also brightened. That is, gray levels are expanded. And when you apply inverse log transformation, obviously the gray levels will be compressed off. And the next transformation is power law transformation, which is given by the expression of output gray levels S is equal to C into R power gamma, where C and gamma are constants. So this value of gamma determines the level of enhancement which you are providing. See here, so varying this gamma value, we can able to get the enhancement. For example, if gamma value is less than 1, the dark area is enhanced, like log transformation. When gamma is greater than 1, bright area is enhanced. Brightness is increased actually. We will see with the example. So this is the MRI of upper thoracic human spine, which is fractured. Right, and this picture is predominantly dark, so I have to brighten it. So I have to provide the gamma value to be less than 1. Only then brightness will be increased. So gamma value is kept as 0.6 here. Somewhat the brightness is increased. If I reduce the gamma value, still more brightness is increased. And if I go on reducing the gamma value, brightness is increased. So which shows that when gamma is less than 1, brightness is increased. And here this is a aerial view, and where I cannot able to visualize certain details clearly, so I have to darken the image. When you need to darken the image, gamma has to be made greater than 1. So for various cases, here gamma is made as 3, gamma is made as 4, and gamma is made as 5. And here also you have to choose a proper value of gamma. When you go on increase the gamma value, image might be darkened more, which might result in two dark areas which might not provide you the better appearance. So that here either gamma 3 or 4 provides you the good appearance, so that you can prefer 3 or 4. And the next algorithm involved is contrast stretching. The contrast stretching, these contrast stretching, intensity level slicing or gray level slicing, and bit plane slicing are referred to as piecewise linear transformation, which tries to expand the range of intensity levels. Right? First we will see about contrast stretching, which tries to expand the range of intensity levels so that the contrast is expanded throughout. This contrast stretching is actually applied to enhance the poor quality image. If suppose the image quality is very poor, I need to enhance the contrast. Contrast stretching is preferred. So the poor quality can be due to poor illumination or wrong lens aperture or wrong shutter speed. So I have to increase the dynamic range of gray levels. So this is the input image which is taken with dull contrast. Contrast is enhanced by means of applying this type of transformation function, where for certain range one type of transformation is applied, for another range another transformation is applied, because dark area is retained as dark and this area which need to be brightened or brightened. So depending upon our requirement, we are varying the gray levels. This is performed by contrast stretching. Next one is gray level slicing. Gray level slicing tries to highlight the specific range of intensities alone. It can be done by two form of approach. One approach is that setting all the remaining values which is not of interest to be black and only our interest to be white, to be proper color. Whereas another form is that remaining areas are maintained as such and only our required areas is brightened or darkened. Right? So this can be applicable to enhance the features which are of required interest or otherwise enhance the flaws. For example, this is one form, retaining other values to be low value and only our required area of interest to be of high value. That is required area alone brightened and remaining all are darkened. In the next category is required area is brightened, leaving the other area to be as such. This is called as gray level slicing. Highlight the major blood vessels and which helps to study the shape of the flow of the medium. And likewise here, remaining areas are maintained as such and only our area is highlighted more. Last category is bit plane slicing. Instead of highlighting the gray level ranges, we are going to highlight the contributions which are made to the total appearance by means of bits. Higher order bits will obviously provide major significant data and lower order bits will provide the least significant data. So you can highlight the image based upon the bit plane details. So for example, this is the original image and bit plane 7, 6 and likewise if you go on, you can able to visualize that higher order bit plane provide you the major detail and minute detail are provided by the lower order bit planes. These are the references which are referred. Thank you. Thank you.